Okay, these are the notes on coordinate geometry. So we're taking what we've learned about parallelograms, rectangles, rhombus, and squares, and using coordinate geometry to describe these shapes. So we're going to go over the steps. Step 1, when we're using coordinate geometry, check the congruency of sides. This pin's not working. Step 2, check congruency of diagonals. Alright, so looking at case 1, a parallelogram, opposite sides are going to be congruent and diagonals are not congruent. So that means opposite sides will show congruency, but not the diagonals. Okay, case 2, rectangles, again, opposite sides will be congruent. So I can make those marks. And diagonals are congruent. So this one's going to be different in the fact that these diagonals, when the full diagonals are congruent, the halves are also congruent. So I used a different color there. It's kind of hard to see, but those are also congruent. Next, case 3, a rhombus. All 4 sides are congruent, and diagonals are not congruent in a rhombus. Because you got to think, like, if these two sides are being squished together, these two angles, this diagonal is going to be much longer than this one. So all 4 sides are congruent in a rhombus, but the diagonals are not. Okay, case 4, a square. All 4 sides will be congruent, and the diagonals will be congruent. Use a different color here. Come on, pen. Work with me. Use a red pen. Alright, so what we're going to do here is we're going to plot the shape, we're going to take the measurements of each side, and we're going to figure out what kind of shape this is. So A is at 9,4, and we're going to need to draw in the axes, and I'm kind of seeing that 9 and 8 are the highest numbers, so I'm going to move a little bit to the left because I know I'm moving right quite a bit. So I'm going to put my axis over here somewhere. Okay. Now all I gotta do is plot my shape. 9,4. 2. There's A. B is 8,2. 2, -5. 3, -7. Okay. Okay, so that was A, B, C, D. Alright, so I want to check. Again, first thing we need to do is check all the sides. We need to know what's going on with the sides, if they're congruent or not. So let's prove that first, the side length of CD. So CD. So I'm going to use those 2 points. CD equals. So CD is 2 minus 3 squared. 2 minus 3 squared, and then -5 minus -7 squared. Work that out, you get 1 plus 4. Square root of 1 plus 4 equals the square root of 5. So.
No, I'm just gonna return like the notebook.
Okay, yeah. Set it down here.
The only thing that I'm missing is like 1 through 9. Or
Okay.
beginners.
Yeah, that's fine. That's fine. That's a lot of stuff in the beginning. Okay, next we're going to prove the length of AB. And AB is going to be 9 minus 8 squared. You can just set it on the table. Like right here. And negative 4 plus 2 squared. Work that out, you get 1 plus 4 equals the square root of 5. So, CD and AB are congruent. Okay, now let's see the length of CB. Eight minus negative 2. Just 8 minus 2 squared. Correct myself. Plus negative 2 plus 5 squared. Come out to 36 plus 9, which is square root of 45. Now I want to find the length of AD. Nine minus 3 squared plus negative 4 plus 7 squared, and I get 36 plus 9 equals the square root of 45. So I know that CB is congruent to AD. So we know that this has the possibilities of being a parallelogram so far and a rectangle, because opposite sides are congruent. Notice that the opposite, not all four sides are congruent, just opposite. So now we need to check whether it's parallelogram or rectangle, so I'm going to use the diagonals to do so, because in a rectangle, diagonals are congruent. In a parallelogram, diagonals are not congruent. So let's check the first diagonal. Let's go from C to A. Check diagonal CA. So using the distance formula, 9 minus 2 squared plus negative 4 plus 5 squared I get 49 plus 1 equals square root of 50. Okay, I checked CA, now let's check DB. 8 minus 3 squared plus negative 2 plus 7 squared. You get 25 plus 25 equals square root of 50. So the diagonals are congruent, making ABCD is a rectangle. Okay, so watch the next video. Now I'm going to go over number 2 and number 3. Oh, and again, where I'm getting this formula, this is the distance formula. So if you want to write this at the bottom, I get x1 minus x2 squared plus y1 minus y2 squared.